Hello everybody, welcome back. Today we are going to be doing quadratic inequalities. Now, first of all, with inequalities in general, we should know that inequalities is essentially when we take some type of interval, right? And I'm going to use straight lines because I clearly cannot draw straight lines. If we take an interval, right, and we say, if we have an arrow such as these, right, this indicates that we are working from negative infinity until positive infinity. So from the lowest point that can ever exist on the x-axis until the highest point. So usually we work within the x-axis with inequalities within high school. Okay, and then when I say that, let's say for example we have some point 0 on the point on the axis, sorry, yeah, hectic, the interval. And if I say that I'm going to write down a circle that's closed and I'm going to point it all the way towards infinity, then that indicates that our x value lies between 0 until positive infinity, right? And it's excluded. So notice that we always exclude infinity or negative infinity. Why? Because we can never actually get to infinity. It is endless. So we can never possibly get to infinity or negative infinity. And notice that because we have a closed circle, it will be a closed bracket, a square bracket, right? And what if it was a case where we had a open circle, such as this? If it was open, then therefore the bracket that we'll use is the same as the infinity, meaning we are not actually at the value 0, but we are actually close to the value 0. So we are not touching it, but we're just by the right hand side of 0. Okay, so it's 0 excluded. So what would happen if we talk about quadratic inequalities? Because this is just linear inequalities, right? We're just working with one set of of values and whatnot. So we want to work with multiple different ones, in this case over here. Okay, so if I give you a question such as solve for x if x squared minus 3x minus 10 is going to be greater than 0, then therefore what are we going to do? Well, we only know how to solve linear inequalities, so why not just factorize it into two linear equations, right? Because if we do factorize this, notice what we get. If we're going to factorize this, we're going to get x, and x gives us x squared, and then what gives us 10? 2 and 5, right? And 1 and 10. But what gives us 3 out of those two combinations? Clearly 2 and 5. If we say 5 minus 2, we'll get 3, okay? So then from here, we are going to have x on this side, and then x on that side, and then we're taking 2 and 5. Because we have a negative as the first operator, we're going to put that as the biggest value, and then the remainder is going to be the negative multiplied by the first operator, which gives us a positive for the remainder. And remember that the inequality that we're working with is greater than 0. Now what do you notice here? We notice that we have two different brackets that are greater than 0, but we can't really solve it like we usually solve for x, when we take each one and let it be greater than 0, because why? There's so many conditions that it can really fall into. This one can be negative and negative at the same time to give us a positive value. This one can also both be positive, but that would have restrictions, and then one of them could be negative and then positive on the other one, and then obviously this would be incorrect. So that is why we are going to use a different method on this one. So these are the steps. You first factorize, then the next step you find your critical values. Critical values, I'm going to write it in full, so it's going to be critical values. Okay, our critical values is how we usually solve for x. We treat this as an equal sign temporarily, such that we say x plus 2 is equal to 0, or x minus 5 equals to 0. So this is just a step that we do. We're not actually solving for our x values this way. We are just getting our critical values, and that is our method. Therefore, x is equal to negative 2, or x is going to be equal to 5. Okay? So since we found our critical values, what do we know about quadratics? Isn't quadratics just a parabola? right? Because a parabola has some type of equation to the second degree, in this case over here. So we would call this the parabola method. So with the information that we have, we are going to draw a line on the x-axis, okay? Because remember, we're working with x values, right? It's x equals and x equals. We'll just put these 2 points on the x-axis. So we'll have -2. Let me put the -2 here. And then we'll have another point, which is 5. The scale doesn't matter in this case. And what is this? The x-axis, right? And we are going from -infinity until +infinity for this one over here. And then we just draw a parabola at those points that we have, okay? So the parabola will always be concave up that we are using. Okay. Now that we did all of this, in order to find out the actual answer, we need to look at our inequality. When the inequality, and I'm going to write it down here, right? If it is greater than 0, then what are we going to have as an answer? It is going to be above the x-axis. Okay, and if it is less than 0, then it is below the x-axis. And the x-axis is obviously this one, right? This is the x-axis. So what do we have? Obviously, we can also say equal to as well. It really doesn't matter, just as long as we have this sign and that sign, but it is greater than 0. So what does that imply to us? It implies to us that it must be above the x-axis, meaning it needs to work with this interval above the x-axis. And what interval is that going to be? It's going to be this interval all the way, and then it's going to be this interval here. So all the way from -infinity until 2, and all the way from 5 until +infinity. Can you see that? If it was less than 0, we would work with underneath the x-axis, and we'll be working with this region. But clearly, we won't be working with that region. So this implies to us that our x values is going to be from, so we'll say x is between -infinity until 2. But my question is it included or excluded? Clearly, there's no equal sign over here. So we exclude it. And then we say union. And then we say 5. Because it's excluded, we say 5 until +infinity. Obviously, you could either say that, or you could say it in the form of your other, if you use like inequality signs, and you can say x is going to be less than 2, or x is greater than 5. This is also another way that you can say it. Okay. So those are the 2 ways you can say it. If you use this method, that's how you do it. If you use this method, this is how you do it. We do another example and we can call it a day. Okay, so I know that I said that I would do this and then call it a day, but I do want to do one more example because this stuff is a little bit funny when you get into it for the first time. So let's do a different case over here. So we need to solve for x if x squared minus x is less than or equal to 12. So first things first, we want to get it in quadratic form. Obviously this isn't an equal sign, but we will still treat it as if it was a quadratic equation. So we'll take the 12 over and get 0 on the other side like we did with the other question. But in the other question, it was by default on the other side. So x squared minus x is going to be minusing by 12, and this is still less than or equal to 12, okay? Because you just took the 12 over. And then from here, what do? We need to factorize, okay? And notice that on x squared, we have x and x. 12, we can have 3 and 4, we can have 2 and 6, and we can have 1 and 12. And which combination gives us 1? Well, clearly 3 and 4 gives us 1, so therefore we will use that. So I'm going to say x, and then we're going to say 4, or I'll say 3, and then x and 4 is less than or equal to 0. And then the signs, the biggest one gets a negative. Negative and a negative gives us a remainder, which is positive. Okay. So from here, we need to do the same thing that we did in the previous one. In the previous one, we took each bracket and we let it be equal to 0 to find critical values. So our critical values, so I'm going to write here, critical values is going to be what? Where x plus 3 is equal to 0, or where x minus 4 is equal to 0, and then x is equal to negative 3, or x is equal to 4. Okay. So in that case, what we're going to do is we're going to draw our parabola. Okay. So we're going to draw a parabola in this form over here. So we're going to have the parabola, and then we're going to draw our arrows, notify that it's the x-axis, and we are working from negative infinity until positive infinity. Remember, some of these things are very optional. You don't have to write the infinities, but I usually write it to help me. And then what are the points that we have, right? We have negative 3, and then we have another point, which is 4, and then we just do our parabola. Okay. So what do we notice about this? We're saying that these two brackets are less than or equal to 0. What did we say in the last one? In the last one, we said if it is greater or equal to 0, or if it's greater than 0, it's above the x-axis, but if it's less than, or if it's less than or equal to, it'll be below the x-axis. And what do we notice here? It is less than or equal to 0. So therefore it's below the x-axis, meaning we need to work from the point negative 3 until 4. Notice that from negative 3 until 4, it is below the x-axis for the parabola. And is it included or excluded? It's included. So therefore our final answer, and I'm going to give both forms over here, is x is between included, negative 3 until 4, included. Or you could say x is between negative 3 and 4, included on both sides. Okay, now that is essentially how you deal with all of this. Obviously the reason why we always have a positive parabola is because notice that it's a positive quadratic, and if there's a negative in front of the coefficient, usually we would take a negative out as a common factor. So there is something that you can take note of from this. Okay, so that was a case where we have it below the x-axis, where it's less than or equal to something. 0, sorry. Let's do a case where we can't use normal factorization and we have to use the quadratic formula. Alrighty, so here's a case where we have x squared plus 4x minus 11 is less than or equal to 0. So from here, notice that when we want to factorize, we have x and x, that gives us x squared. But because 11 is a prime number, it's 1 and 11. And 1 and 11 doesn't give us 4. So that's a problem. And notice that we only have a coefficient of 1 by the x squared. So we can't really do any grouping method to find out the factors. So therefore we have to use the quadratic formula. So for the quadratic formula, we need to do the following. X is equal to negative b plus minus the square root of b squared minus 4ac, all divided by 2a. Okay. And then notice that we need to find out what is our a, b, and c. Well, our a value is actually just going to be 1. So this is our a value. Our a value is going to be the coefficient of x squared. Our b value is the coefficient of x, which is 4. And then our c value is just the constant, which is negative 11. So therefore, what we are going to say over here is we're going to plug the values in. Okay, so x is equal to negative into our b value, which is 4, plus minus the square root of 4 squared, minus 4 into a times c, which is going to be 1 multiplied by negative 11. Okay, and then from here, we can say this is all divided by 2a, which is 2 multiplied by 1. And then here, what we can say is that x is equal to, now we can simplify this and say it's going to be negative 4 plus minus the square root of 4 squared, which is a 16. So I'm going to write this all down over here. It's just going to be 16 minus 4 times negative 11, which is just plus 11, right? And then 16 plus 11 is just equal to 27. But then I just realized how dumb I was, because it's not 11, it's 44, because it's 4 times 11. So therefore it's not 27. And then from here, and then this should be 60 in this case over here. Okay, so therefore we can have the square root of 60. And I will teach you how to actually do this without a calculator, but if you are allowed to use a calculator and you're too lazy, I guess go for it. But in this case over here, this can be rewritten as, because we have a denominator between two terms, we can actually split it up with a plus minus sign. So therefore it'll be negative 4 over 2 plus minus the square root of 60 over 2. Okay, and we can obviously simplify this further by saying negative 4 over 2 is just negative 2 plus minus. And then what is going to happen? Square root of 60, can we break this up into anything? Well, if you think about it, right, we want a perfect square multiplying this. So what happens if we take the perfect square? The first perfect square we can take out is actually 4. And we can break it up into factors of 4 multiplied by 15. Isn't that kind of like, okay, not really what we did over here. We just added, so like, I'm going crazy here. We know that 60 is equal to 4 times 15. So if we say the square root of 4 multiplied by 15 over 2, do you notice that if we use the rules of square roots, which tells us that the square root of a times b is the same as the square root of a multiplied by the square root of b, then therefore we can use those rules and we can say the following. We can say that it's going to be negative 2 plus minus the square root of 4 multiplied by the square root of 15 over 2. And we know the square root of 4 is equal to 2. So we can actually just cancel them over here. Because remember, this is equal to 2. And what are we left with? We are just left with negative 2 plus minus the square root of 15. Because we had 1 at the denominator. So therefore, like, yeah, it just becomes root 15. So what does that imply to us now? Since we have this actually just implies to us that x is either equal to negative 2 plus root 15, or it will be negative 2 minus the square root of 15. Okay, so there's two cases that we have over here because of the plus minus, and those are our two roots that we can have. Obviously you can just plug it all in your calculator, but I wanted to just show you, like, you can still use rules to get as simple as possible, because some schools don't use calculators. So it would be nice that I show both sides. So these are our two roots. Now in this case over here, we can just take note that the square root of 15, right, lies between, or I guess we can start off like this. We need to create the square root of 15 to see what the approximate value is, and then we need to look at this value and see if it's going to be negative or positive. So which means we're going to have 15 lies between two perfect squares. And which perfect squares do we have? So let's say it will be about 9, and it'll also be between 16. Because 15 lies between 9 and 16. And if we take the square root on all sides, notice we have the square root of 15 now. But this implies to us, so I guess I can write it here, that we're going to have 3 root 15 and 4. So root 15 lies between 3 and 4. So therefore it's bigger than negative 2. So negative 2 plus that, or we can say, let's just say that it's approximately 4. Then we would say negative 2 plus 4 is still going to give us what? A negative value. A positive value, sorry. And then for this one over here, we can say here that negative 2 minus 4, approximate obviously, is still a negative value. So therefore, this one is the lowest, and this one is the highest. And like I said, this is if you don't have a calculator. You can just use this method. So therefore, what that implies to us is we can use our parabola method. And we can say that this one here is just going to be negative 2 minus root 15. And then the next one is just going to be negative 2 plus the root of 15. Okay. And we just do our normal parabola. and then we have our x-axis, and it's from what? Negative infinity until positive infinity. And because what was the initial one that we had? It was less than or equal to 0, so it's below the x-axis. Okay. So since it's below the x-axis and it's also equal to 0, then therefore that just implies to us it's going to be between. So this implies to us that it's going to be either, you can either write it like this: x is element of closed negative 2 minus the square root of 15 all the way until negative 2 plus the square root of 15 closed. Or you could say that negative 2 minus root 15 is going to be less than or equal to x, and x is less than or equal to negative 2 plus root 15. So these are the two different ways that you can write down your final answers, and that is quadratic inequalities.